Hello, this is Lee the Squirrel, and this time of class we're going to do prime factors, and this is lesson 3 of chapter 6, and this is page 185. So let's get started. So before we start getting ready, let's talk about what is a prime factors. Well, prime factors are numbered like these, that numbers that cannot be, that can divide it evenly only by 1 or by the number itself, while a composite number is a number that can be multiplied by not 1 but at least more than 2. So composite number should be have at least multiple of prime factors, which is at least more than 2. So for example, 8 is a composite number because it can be expressed as 2 multiplied 2 multiplied 2. And also, let's say 26 is also a composite number because it can be expressed as 2 multiplied 13, which is 2 prime factors. But meanwhile, such as number like 61 isn't. Well, you can express it in any ways. For example, if you try to divide with 2, it will be a 30.5 as it is a decimal. And decimal, it can be divided, but it is not a whole number. So even if you divide with any number, prime factors, you cannot divide with any numbers by making a whole number, which is, obviously more than 1. So you cannot create a whole number except 1. So even only 61 divided by 61 can make 1. And this is the only exception. So number except 1, you cannot, make a whole number with any division. 2, this would be, 30.5. If you divide it by 3, it would be 20.333, and if it is 7, it would be, let's say it is going to be 8 and 8.7, you know the drill, and blah 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 blah. So this was the definition of prime factor. So by knowing this, let's go to getting ready. So getting ready. Okay, so getting ready, it is, how can we solve this problem? Like, it is finding the composite number that has, which is at least more than 2 prime factors. The number of the prime factors should be at least more than 2. So there are 2 ways to solve this. One is just memorizing all of them. Just memorize all. There's about 25 numbers. Well, not exactly. There's exactly 25 numbers of prime factors below 100. So you can memorize 25, or another way is you can try to divide 2, 3, or 5, or 7. And if you divide with these prime factors and the result doesn't comes out with decimals or fractions, that would be pretty much a prime factor. How do we know? For example, 11 multiplied 11 is 121, but 11 multiplied 7, it contains 7 and it is below 100. Or let's say 80 and 98. You can divide, this is obvious, you can divide with 2. Or 99, this is a number with 11 multiplied 9. So there is a 9 anyway, and to avoid this, it should be containing at least more than 2 same prime factors. Then you can avoid to use these. 9, by the way, consists 3 multiplied 3, so it consists 3. So the number below 100, or a bit more accurate, below number 120, and if you try to divide one out of these four and it doesn't comes out with a decimal or a fraction, that number would be pretty much a prime factor. So let's try it. So number A, like this number, well, if you divide, this is an odd, so if you divide with 2, it will pretty much be a number with a 0.5. So let's pass it out. Then if we do with 3, well, 3, let's see, the closest number that you can divide with 3 is 52. But 53 is too big for that. Well, a bit awkward for that. So 3 is, you cannot divide with 3. It will comes out a fraction, which is not possible. Well, not available for a composite number. And try 5, and this would become out 10.6, and it is a decimal. We don't want decimals here. We want to find a composite number. How about 7? 7 is 7.7 and 4 over 7. So this is not a number we want. We don't want fractions from here. So A is a prime factor. This is a prime factor, and this is not a composite number. How about 66? Oh, this is odd. Well, this is even. So if you divide with 2, it becomes 33. Okay, you can divide this. So this is definitely a composite number. And let's see, this is 54. Oh, 54 is even. You can divide with 2. Or, well, so as you can divide with 2, this is definitely a composite number. 2, it would be 27. And you can also divide with 3, by the way. And 80, this is obvious. 8 is already 2 multiplied 2 multiplied 2. And this number would be just obvious. Well, this is an even, so this is a composite number. How about 61? 61. Let's try to divide with 2, and it comes out with a 0.5, well, like 30.5. It's a decimal. No, it cannot be. How about 3? This comes out with 20 and 1 over 3. We don't want fractions. Come on. How about dividing with 5? This again, no, not again. 12 point, what is this? This is 4, right? No, 2 is 12.2, and this is decimal anyway. We don't want decimals here. How about 7? 7 is, let's see, this is 8 and 5 over 7, and this is a fraction. We don't want even fractions, so this is pretty much a prime factor. So this is not a composite number in other ways. 47 divided with 2 is 0.5 number, like 23. We don't want decimals. How about 3? It is, well, 15 and 2 over 3. We don't want fractions, so pass. 5, 9 and 2 over 5. We don't want fractions, pass. 7, this is 6 and 5 over 7. We don't want it, pass. This is a fraction, so this is a prime factor. How about 59? Well, let's do it. 2, nope. This is 29.5. This is a decimal. Hell no. 3, how about this one? This is 19 and 2 over 3. We don't want it. 5, well, it is the same. We don't want it. It's going to be ended with 4 or 5. 7, nah, it's not going to happen. 8 and 3 over 7. We don't want it. So this is a prime factor. Well, 8 is even, so I'm going to skip it. This is definitely a composite number, as you can divide with 2. 25, you can divide with 5. So it could be 5. So this is a composite number. 48 is a, well, you can divide with 2. 49, this is 7 multiplied 7. So be careful. But it has 2 prime factors, so it is a composite number. 85, you can divide with 5. This you can divide with 2, and it becomes a irregular whole number. So these are the circle numbers are the composite number. Thanks for watching.